All right, friends, we need to start talking about that question. So, up here, your attention is, I feel like I'm talking like Yoda all of a sudden. Up here, your attention is scientists. So, there are some words in here that we need to make sure we understand before we can answer the question. Right, Haley? Yeah. Awesome. Okay. So, the first one is water table, and that's a word that you approached yesterday when you were building your aquifer. What is a water table? Or what is the water table? Yeah.
It's like the level where the water is.
The level where the water is. Ladies, write this down. So the water table is the level where the water is. Is the water table above ground or below ground?
It can be both, right?
What do you guys think? Beth says it could be. What'd you say?
Both.
It could be both? Liz, you agree? Mm-hmm. She's shaking her head. The people who are originally named Elizabeth are in agreement here. Yeah, yeah. How is that possible that it could be above or below ground if it's all the same level? There's what? Well, so like the water table in Iowa, in the Iowa City area, it does change. So sometimes, so that's another thing we need to write down, is that the water table, the level can change. Oops, can change. Hold on just a second. Go ahead. Yeah, go ahead.
Is it like the level of water is like the same, but then like the ground levels are different?
Okay, so that's one part of it, right? Is that the part you were talking about or no?
We can go with that.
Okay. The reason I ask is that there are kind of two different ways to answer the question that was kind of nebulous. So one of them was, say it one more time, Sydney, what did you just say?
The ground level can change, the water level will be the same.
So the ground level changes, right? People on the coast think that Iowa is super flat. Is Iowa completely flat?
No.
For sure it's not, right? We've got hills, we don't have mountains, but we've got hills and we've got valleys and things like that, right? So if we let's just draw a little landscape here. Go ahead and you draw a landscape, I'll draw a landscape. It's going to have a hill and it's going to have a dip, right? This is a hill. In case you didn't know, you couldn't tell, I'll put a tree on the hill. There you go. Choop, 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 choop. Yeah, it's a cute little tree with a hill. If the water table is the level of the water, if you're laughing at my picture, then I'm going to show your picture.
No, I'm laughing at Maddie.
Oh, we got to show friendliness. Come on now. If the water table is down here, then this thing here would just be a valley, right? If the water table was up higher, though, that means there's water under the ground here. And what's right here? A pond, right? Or a lake. Or depending on how this is all put together, it might be a river or a stream, right? But a lake or something like that. So the water table, depending on the level where the water is, and depending on what the topography of the space is, the water table, which is this level here, can be above or below ground, right? So that's one way in which it can be above or below ground. But then, Liz, you said that it could change. You are not wrong. In fact, you are correct. And it's exciting. How does the water table change? It can rain, right? Precipitation, water cycle. If we get a whole lot of precipitation, what happens to that water when it hits the ground? it sinks down in, right? Some of it runs up, but a lot of it sinks down. And as it sinks down, it's got to go somewhere, and it's going to go into the water table, into the, what do we call this water that's under the ground? Groundwater? I mean, that's kind of obvious, right? Groundwater, water under the ground. Yeah, for sure. So this is groundwater down here. And if you have a big, like, section of groundwater, a big, like, storage of groundwater, what else can we call that? Starts with an A. An aquifer, right? Did you know that one of the largest aquifers in all of the world is just one state over? Mm-hmm. Yeah. Underneath one of the flattest states, in my opinion, in terms of having to drive across there, right? Yeah. You guys know where, you know what's right just west of us? What's that? Nebraska. And under Nebraska is one of the largest aquifers not in the United States. It is the largest one in the United States. One of the largest in the world. They may know what it's called. Starts with an O. Aquifer starts with an A.
What starts with an O?
The name of the aquifer. Ogallala. You are not as far off as you may have thought. It's the Ogallala Aquifer. It's underneath Nebraska.
Oh, Ogallala is
It's also yes, it is a town in Nebraska, also named from the same thing, right? I think it comes from a Native American word, okay? Don't know what that means off the top of my head, but I'm sure we could look it up, okay? So the aquifer, which is just a storage of groundwater, one of the largest ones in the world, is not too far from us. And that's where a lot of people get their water from. Now, we said, and we kind of answered it, but I didn't actually draw it in here. When it rains, what happens to that water table? It goes up, 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 up. And that can cause a lot of flooding too, can't it? It just keeps going up and up and up. And as it goes up and up and up, there's no place for that water to go to seep down into the groundwater because the ground is saturated. And so that's where a lot of that flooding comes from. Okay. The second question, any idea how you think, or do you think that the flooding has affected the groundwater, like the quality of the groundwater? Talk to your tables about that, because I didn't really articulate it that way before. How do you think that the flooding, if at all, has affected the quality of the groundwater? I'll call on you in just a second, Haley, so you can answer it.
Me?
What did you come up with? I want to talk to people that I haven't talked to yet today. What did you come up with? How do you think that the flooding has affected the quality of the groundwater?
Hi.
Thoughts?
No. You think it has an effect?
Do you think it's just stayed the same?
Well, sure. It's affected.
How has it affected? Has it made it better or worse?
Probably a little bit worse.
Probably worse. In what ways do we think it might have been worse? I'm just going to write this down here. We think that maybe it has decreased the quality. Of the groundwater? Yeah, go for it.
This isn't like a direct answer, but like down in the south when they have the floods, it's like unsafe, so I'm assuming it's worse because there's like pollution.
Absolutely. So down, you mean in like the southern United States, is that what you're referring to? Or like southern Iowa? Or both? Southern United States. So you have experience, you've heard about this, that when they have flooding in the southern part of the United States. Tell me, I just wanted to know a little more about your story.
Aren't they like not supposed to like swim in it or whatever, so it's unsafe, so you can't really like swim in it and it's not good for you.
It's probably not good to consume it either, right? Yeah. So it decreases the quality It makes the water unsafe to swim or to consume. All of these things are true. Yeah. Where does it come? Why? What's making the water unsafe?
The chemicals we put on our soil.
Yeah. For the soil. And we don't usually just spray chemicals on the soil. What are we spraying the chemicals on? On our crops, aren't we? Those pesticides that farmers put on the crops to make the crops grow. And I really want to make it clear that I'm not trying to demonize farmers, okay? My uncles are farmers, and I totally get it. And there are some things that have to be done. But every time that they spray chemicals onto the crops, a lot of that chemical stays on the crops and keeps the bugs away so that the corn can grow, so that the cows can eat, so that you can have your milk or your beef or your whatever, right? Okay? Or, whatever iteration of that you have. But what happens to some of that chemical, you guys? Where does it go?
The soil.
It goes into the soil, and then it rains a whole bunch, and then that water pulls it down into the groundwater, right? Yeah. We're going to watch that today. We're going to see how it goes. Would you pull out your lab sheet? Okay? The aquifer sheet that you had yesterday. I am going to tell you your list of tasks. And once you know your list of tasks, then you can go ahead and get started with your group, okay? Task number 1, if you have not yet done this, task number 1 is to finish the front side, okay? Which means that you have to have answered all of these questions. Question number 9 or task number 9 asks you to draw a picture with the water table and all of those things, okay? Labeling the saturated zone, etc. And then answering question number 10. Please make sure that everyone in your group has finished the front side before you move on to the back. You may have noticed that I was walking over to the cups while you guys were answering the capture question. That was because it's really dry, and I was wondering how much of the water had evaporated overnight. We wanted a lot of it to seep down, and that's good, okay? But I also want you to take a look at the water table as you look at the back. So flip your page over to the back just for a moment, okay? On the back, now we're going to start talking about using that well. What are we using that looks like a well, or that we're simulating the well with? The straw, right? We are going to use this groundwater as a source of drinking water. That's what the Ogallala Aquifer is used for, okay? We get our water from rivers, but that comes from the same kind of sources, right? Okay? It's also a source for plants and crops. Wells are going to use to pump water out of the ground. Has anybody ever consumed water from a well, either at your house or maybe when you've traveled somewhere? No? Oh my gosh. I see a couple, but I was like, I'm just surprised there aren't more of them. Interesting. Okay. Well, you should do it sometime. Oh, it's fun. Anyway.
Well, I know it's good.
I mean, that's what my house has. We just have well.
You just have well water. Yeah. Yeah. That's how my grandparents' house is too. So that's why, yeah. Yeah. So I'm just like, yeah. So then you're going to start on question 1 and you're going to run down this way. So you are going to simulate some pollution. Okay. The pollution that we're going to use is blue water because then it'll be easy to see it. So in part 3, you'll come up to me and get a little blue pipette with some blue water in it. You're going to pour it. I want you to underline this right now. If you're a highlighter person, you're going to highlight this right now. Okay? You're going to pour it by the well, but onto the gravel. Okay, so this is on the back. Please don't be answering the front questions right now. Please turn your paper over so that you're paying attention right now. Please turn your paper over so that you can mark this right now. This is on part 3. You're going to take the blue colored water that you're going to get from me and put it by the well onto the gravel. Then you're going to watch some observations here. when you get to number 7, there's I don't want to say typo, but I'm going to just change it here. It says we're going to then pull out water from the well. So you're going to use a little pipette to pull water from the well. It says to put it in a beaker, but beakers aren't super good for measuring volumes of, small volumes. So instead, what is another lab tool that we can use that we talked about yesterday? Not a test tube, because remember, those don't have the little lines. Yeah, there you go. So you're going to use a graduated cylinder here. Okay, to pull up that water. And then you're going to answer these questions. You're going to answer these questions. You're going to get to question 11. Once you get there, you need to let me know. You'll come back and sit down. Well, you'll clean out your stuff, and I'll show you how to do that in a minute. Okay? And then depending on where we're at, I'll probably have you work on something, or we'll come back as a group. Okay? Does that make sense? Yeah. What's the first thing that you're going to do? Answer the questions on the front. Once you've done that, you'll go get your aquifer, or I guess you can get that first so you can draw your picture if you have not done that yet, okay? Please also, and I didn't say this before you start question 1, I would like you to fill up your aquifer so that it is full to the water table level, okay? So fill to the water table level again, just so that you are sure that does that make sense? Okay. And then again, once you get to question 11, let me know and I'll tell you what to do next. All right, go.